Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi everyone, welcome back to Geeks and welcome back to another live mock DSA interview. My name is Yash Dwivedi. Currently, I'm working as a DSA mentor at Geeks. I'm a candidate master on code courses and 5-star on code chef. So all of you can quickly give me a +1 in the chat if my voice is clearly audible and everything is working fine so that we can start with the mock interview. Okay, I'm just waiting for 30 seconds for your replies. You can give us a +1 in the chat and like the video as well so that we can call our guest for today. So let's call Aditi. Hi Aditi.
Hi, Yash.
How are you?
I'm fine.
So can you quickly introduce yourself for the audience?
Yes, so I'm Aditi Dey. I'm presently in my final year. I'm pursuing BTech from Technomain Soltech with a major in information technology. My technical skills include DSA in C++ and other subjects like object oriented programming, DBMS, and OS. And apart from that, I've done 2 3 projects on web development and machine learning, and I'm really excited to mock with you. So
Okay, great. So you can quickly share your screen so that I can share the problem as well. Down there, you will see a share tab is there. So there you can share your
yes,
screen. Just quickly share your screen and then I'll share the problem with you. Yeah,
so yeah,
fine. It's visible. So if you will now open the private chat. So you can see in the private chat section, you can exit full screen. And yeah,
yeah.
you will see in the private chat, there is a question. Yeah. Please quickly open that question.
Okay.
Okay, fine. So let us start with this question. The question name is restrictive Candy Crush. Okay. Now, in
Yes,
this question, what I will be giving you is, I'll be giving you a string. Okay. So you'll be given a string. Let's name it as S. So I'll give you a string S and I'll give you another integer that is K. So two things are given. One is a string S. Another thing is an integer K. So the task is to reduce the string. Okay. So basically you have to do what? On this string, you have to perform some operations so that you have to reduce this particular string. What do I mean by reduction? So basically when I say reduction, so basically this means that in this given string, you have to choose a group of k consecutive identical characters and remove them. Okay, are you understanding? Like in this given string, let's say I say that k is equal to 2. So in that case, you can see in Geeks, uh, double E is occurring 2 times. So it is a cake. It is satisfying this condition that the characters, consecutive characters, are same. So that is why you will remove these two e's. Like if you will see k is equal to 2, and you see this example Geeks. So in this you can see that in this particular example, I can see that uh, double E is occurring 2 times, right? So it is k consecutive characters, not two consecutive characters. So I'll remove
yes,
that. Then again you can see that double E is in the second Geeks also double E is occurring again. So I'll again remove it. You can see now how the explanation is given. Okay.
yes,
So after I removed these two consecutive pair groups, then I'll get this particular string. Is that clear? The output part.
yes. So it's clear.
The first example is pretty much clear. Okay.
Yes,
Now you can
first
scroll
example.
down to look at the second. Yeah, look at the second example as well. Then things will be much more clear to you. Right. Yeah. So let's look at the second example. Now, if you look at the second example, so I will give you the string that is G double E G S F O R G triple E K S. Okay. Now in this string, if you will see now, so you can see that initially double E that is given there, the first double E pair that you are having, it is k consecutive in nature, correct?
Yes,
Right. And you can see in the explanation part that is written there. After that, if you will see further, so After you remove the double E, then the two G's will come together. Are you getting this part? When you erase
Yes.
the two double E's that are there, then the two G will come together. And again, they satisfy the criteria that they are K consecutive characters that are same. Correct? Are you
Yes, sir.
getting this part? Right. So I
Yes,
have to
sir.
remove them as well. Okay. So this is one thing that when you remove, so it's not that you can move forward. You will, if there are, if there is something behind that you should remove, so you should remove it. Okay. Then after that, if you will see, so furthermore, in the second G triple E case that is written in the G triple E case, I have only two consecutive E's, so I'll remove them, and that part will be GEKS. So is this question clear to you? What you have to do in this question?
Yes, the question is clear.
Okay. Audience can also give us a +1 in the chat if the audience is pretty much clear with this question. Basically, you have to remove K consecutive characters. If you remove K consecutive characters, then after that, in the new string that you're getting, if again there's some K consecutive, then you have to remove them as well. As you can see in this example, G double E G S. So double E is removed. Then after that, two G's come together. They again follow the criteria of consecutive characters. So again, I have to remove them. That is the best example that I can give. So if the audience is clear, please hit the like button and give us a +1 in the chat. Okay. So Aditi, what is your thought process? Any brute force that comes to your mind or anything else?
So first of all, basically the question states that we have to remove the like kth repetition of any character, right? Whether it is E, like here in Geeks for Geeks, it is kth repetition. We are getting EE, so we have to remove E here, and
K
so
consecutive, yeah.
yes, okay, consecutive. So the brute force approach can be like the brute force in brute force approach. I think the time will be in O(n) square because we have to compare like it's contiguous. So we have to compare it like if we are starting from 0th index, then we have to compare it with I+1th index. In that case, the complexity will be a lot. So
Uh,
and
okay, so basically you are saying that you let's say you are firstly there, then you remove a particular K consecutive, then you will restart again from the starting. Correct? You will. That
yes,
is why
sir.
you will take. It will take a lot of time. Okay.
Yes, sir. Yes, sir.
So if brute force will take a lot of time, then you have any other alternative for it?
Uh, so I'll use the concept of next greater element. What we have used, that is, I think I'll use stack in this. Like
Okay. Why?
if uh, so if we put all the elements in a stack, and then if we check that so 1 minute. So, but basically in next greater element, we had to find that the greater one, na? But here we have to find that the repeated characters are there or not. So stack will be used. It's confirmed, but I'm thinking the
Okay.
approach.
See, one like you are thinking in the right direction. I will give you one more thought process for it. That you have to, maybe you are saying that you have to use stack. Let's say if, even if that thought process is fine, but will the
Yes.
stack solve your purpose, or along with the stack you should think about a little bit more, something more than that? Because you have to maybe you have to take care of the number of elements that are occurring also, something like that also, right? Like the occurrence of the element.
So if so I'm thinking that if the elements are similar, then we can simply pop that. And like if we are getting similar, like we are putting all the elements into the stack, then if the elements are similar, like in first and second, that is for EE, then we can pop that. And and then the remaining elements I'll push it. Suppose I'm taking a vector as answer, then the remaining elements I can push it there. So primarily I can think
But
of that only.
here the k value is 2. That is why you are saying that if two consecutive elements of the stack will be same, you are saying this thing, no?
Yes, sir, I'm saying that. Yeah.
but uh, but actually if the k value is larger, then that thing will not work.
So if I'm putting all the elements into the stack, and so if I'm taking a counter, then I guess it will work universally. Like initially here in this problem k is 2, so if I take a counter, then uh, like uh, I'm checking that if the stack is not empty, and if the top most element, that is suppose it is e, if it is equal to our current element, then I'm incrementing the counter and I am popping that element. Then
Okay.
I think it should work dynamically, like I'm like taking a counter for that, so in that case it
Okay.
should work like,
So
yeah.
where will you take the counter, or how you will take the counter? Can you tell me that as well?
So first of all, I'll take like a stack, and I'll take a vector to store my answer. Then I'll initialize a counter to 0. Then if I'm iterating it like to the entire length of the string, like I'm using an for loop for iterating it to the entire length of the string, then if I'm like declaring my counter there, and I'm checking, then I'm putting all the elements onto the stack, and then if I'm checking that whether it is empty or not, and the whether I'm checking the matching part, then I can increase the counter there within the while loop.
Okay. So you want to explain this thought process by writing the code?
Yes, sir.
Sure, you can start writing the code if you want.
Okay.
Uh, Everyone can see I have given the question link in the chat, so you can let me know if it opens or not, right? Uh, I've given it for your practice while the interview is going on. You can also try to write the code. Okay. You can do one thing. If in the right side, if you will see that, so you can see there is a font option in the second setting options. You will see that there is a font option. So can you click on that on the top right corner of the problem itself, of the
Oh,
problem
okay.
only.
Okay. I'm so sorry. 1 second.
Yeah. Uh, yes, there only. Yeah. So you can select 16 font as 16. You can select font as 16 and select the theme as Dracula so that audience can see it. Select the theme as well. There only. Yeah. Select the theme as Dracula. Theme part. They. Yeah. You can select it as Dracula.
Dracula.
The
Okay.
second one. Yeah,
Okay. Yeah.
fine. Now it will be better visible to others. So you are going to return the answer in a vector.
Yes, sir. I'm thinking of so if I'm putting it that in a vector, so like if I reverse the string again and finally return it, then I think it should come. Initially I'm taking a vector, but if I reverse that, then I think I'll return string only, but I'll reverse that and then I'll return it.
I do not have any issue with the reversing part. I just want to see how you will implement this concept as of now. So initially you'll start iterating in the string.
Yes, sir. So I think we have to consider edge cases also. So in that, like I have to
Okay.
check whether, yes, so I have to check whether like n is like if n is the size of the string.
Okay.
Yeah, I have to check. Then if n is equal to 1, then I should print my answer. So I have to check that also. And also if
What will
I
you
think
print?
if k is, if n is equal to 1, that means I have only one string, so in that case I'll print only that one, like I'll print answer. If I've taken, suppose I'm taking a string answer, so I'll return this answer basically. So in that case I'll print answer. If n is equal to 1, I'll simply print answer. I'm saying that.
Okay. Can you explain us why you have taken k is equal to 1?
So if k is equal to 1 also, then also I will print only that element. So I think is
Like, can you literally tell me what does k is equal to 1 mean? If I suppose I give you a very large string, okay, and I give you k is equal to 1. So can you tell me what will be the output in that? Or let's say that I give you a string that is named as Aditi, right? And I give you k is equal to 1. So can you tell me what will be the output for it?
so I think it will only remove it will remove all the single elements, right? Like which doesn't have duplicates basically. So in that case, I think the output will be I. Yeah.
You need to think a little bit more. I am saying that I have to remove k consecutives, right? So k is equal to 1. Think about it again. If
So
k is equal
if
to 1, then what will you return?
so it won't return anything, right? Like I'm sorry I said earlier that like I misunderstood. So it won't return anything because if k is
So
equal to
why
1, there won't be
can
any there won't be any consecutive thing now. So like it will directly, like it won't return anything. It will print null.
why can you explain this?
So because there is no consecutive elements. If k is equal to 1, then there won't be any because in our question there was like if there is any consecutive elements, then
See, basically, if a string is named as Aditi, right, and I give you k is equal to 1, so every time a particular character reaches the frequency 1, you will remove it. Correct? Are you getting this point? If
yes.
let's say in Geeks for Geeks, you were getting 2 is when k was given as 2. Whenever you got consecutive characters equal to the k, then you remove them. So basically, in this case, k is 1. So every character will have one frequency, one frequency. So you'll keep on removing them one by one. Nah? So that is why in the end you will have null. Okay, fine. But do you think that you need to write n is equal to 1 also? Because suppose n is equal to 1 and k is equal to 2. Like if n is equal to 1, then you will return null. Are you sure?
So if n is equal to 1, then it won't return anything. No? It will directly print answer only. What will it return? Like if there is a only, then it won't return
But if
anything.
n is equal to 1, then you are updating your answer. No? I think line number 16 and 17, you want them to be in brackets.
Yes, sir.
Okay. So see, you don't need to take n is equal to 1 as the edge case, right? If k is equal to 1, then simply you can say no.
Yeah, I think so. If k is equal to 1, it should work. Like k is equal to 1, it should work.
Yeah, then only you need to return one null. So you can remove n is equal to
Yes.
1 from.
Yeah. So then,
Okay, just do one thing. Write this string GEEGS. There only in line number 25 only you can write it, or yeah, you can write it on line number 12 as well. Fine.
G double E
Don't comment it. Don't comment it. Otherwise, it will not be visible properly.
G double E.
GS. GS. Yeah. Now tell me what will you do in like while you're iterating through the stack. So what will be your thought process for doing it? You can explain this and write the code as well. See, you will get G, then you will push it in the stack or something.
Yes, sir. First, I'll get G, then I'll push it in the stack. Then for I is equal to 1, that is for E, I'll again push that in the stack. And then basically I'll check that, then again E will come. Then I'll check that whether like my top, that is my current top, if it is pointing in I is equal to 2 and my current top is E right now, right? GE we are having. So if they are equal, then I'm simply popping it because we
Okay,
need to eliminate that.
but my question to you is this thing that don't you think that you have to take care of if k is equal to 3 or larger, then can you just check the top and the top element? Like, can you just check the top and the ith element in that case? Okay, let's do one thing. Suppose that k is equal to 3 is given, and update the string as double G triple EGS. Uh, just update the string as double G triple E
GS.
GS. K is equal to 3 for this case. Okay, I'm giving you K is equal to 3. So tell me what you will do now according to your algorithm.
So one thing we can do is like we can take a pair in stack itself. That is, in stack I can take a pair that will count the frequency of that particular element, and I'm taking the character. Like for G it's 1 presently. Like if I'm iterating from starting, for G it will be 1. I think in that, like
Okay,
that it can work.
correct, correct. Because when you have multiple characters, then you should be having a count of the
Yes, sir.
frequency. No?
First, I was thinking of taking counter, but I think we can take as pair in stack itself. I think that should work.
Correct. So basically, second part of your pair will store the frequency of the character.
Yes, sir. Then it should
The
work
consecutive
dynamically.
frequency.
Yes, sir. Consecutive frequency. Yes.
Okay.
I'm commenting this example as of now.
Okay.
So initially, I have to check that whether my stack is not empty or not.
Okay.
I can simply push the elements. My stack is not empty.
Whatever you're writing, you can keep on explaining it as well. You can think out loud whatever you're doing so that we understand properly.
So like this, in this I've done that if the stack is not empty, then I'm simply pushing it, or
But what have
else
you pushed?
I'm pushing the elements. Currently I'm pushing the element and the count of that which I've taken, like
But
G.
you are
For
actually
G
pushing
it's
the index. Like, should you push with S of I, with the ith character, you should push I or something else.
so presently I should push index. So 1 minute.
Are you sure?
Yes, sir.
Also, do one more thing. Just go down and put some enters there so that the code is much more visible to everyone.
Yes, sir.
Yeah, now it's fine.
So basically I wanted to do is like for our example double G, this example. So if G first, I'll take that for G the counter is 1. So then
Hmm. So initially the stack is empty and the counter is 1. So will you push
yes,
the
sir.
index I, or you will push 1?
No, I'll push the index because like for then again for the next element G will be equal to 2, and
Okay.
for again E it should be 1, like this I'm saying. It's printing individually. For that I'm saying,
Well, okay, fine. You can, if you want, you can do it this way.
because I think that will be easier, because for like for G if I'm incrementing the counter, and for E also I'm incrementing 1 2 3, then I think it should be easier.
But you are storing the indexes as the pair, second part of the pair. If you want to write the else part,
In stack,
if you have
no,
a thought
in
process,
stack I'll, yes sir. So in stack I'll use, like I'll store my character and counter basically. So
but you are storing here the indexes, no?
So if it is empty, then
Other people who are watching this live stream, they can comment down their approaches. I am looking at the approaches, so you can comment down. I am just reviewing them as well while I'm looking at it. So you can comment down whatever your approach you think will work. Like Tanish has said the right approach, I think.
so basically in ith index, like the character we have, we can store the index for that. I'm saying that, trying to implement that.
But you said
I'm
that
storing that.
in the pair, you said that in the pair you will have the second part as the counter, na, initially when you declare the pair.
But sir, so in consecutive, like for ith index, suppose I'm taking G right now. So for ith index, I
If
can
you
store
want, you
that
can do a
which
dry run or on paper or anything. We are very
yes.
close to the answer, but you need to think a little bit more. If you want to go forward with this, you can go forward with this code also, as of now.
So can I write the else part once?
Definitely, you can write it. That is what I'm saying. If you want to write, then you want to understand that where.
Yes, sir.
Can you scroll up a little bit?
Yes, sir.
Like basically, can you move down so that I can look down on the code that is down there?
So here.
Okay, fine. Okay, so what you have done is, if your top element's frequency becomes k, then you are popping it out. Okay, fine. Okay,
Yes, sir. Basically, I'm taking like so basically I'm trying to construct in this way that if for G, for initially for G the counter will be 1, then again for the next element there was, I guess it was GGEES, so it will be, the counter will be 2. Then if like if 2 is given, then I'm popping this 2 out, that is GG, I'm popping this from the stack.
okay.
And again for E the counter will start from 1. I'm saying that, that's why I did the else part there. For that the counter should start from there. For consecutively for E, for first one it should be E, then again for the next one it should be like the counter will be 2, like this.
You can finish up your code and then we can try to compile it.
Okay, so if yes.
Can you scroll down? I wanted to see what you have written.
So I'm just
Okay, so what you have
simply
done, can you
pushing
explain it?
the yes, sir. So I'm simply pushing the like elements into my answer string which I've taken. I'm simply pushing my like the elements, the characters, and
Correct. Okay,
the yes, sir. And then in stack, obviously, it will come in reverse order. So for getting the original string back, I have to reverse it.
fine. Okay.
I think it should work.
Did you need extra bracket there? You have taken
Uh,
in the
I
last
think
line that you have taken this.
yes. I guess now it should be fine.
Okay, you can try to compile it.
Okay, I have to
Yeah, you need
comment
to
that.
comment that.
Yes. T minus.
You should write temp, no?
T was not declared. Okay. Think we have got yeah. It's removing E.
Uh,
Yes.
no, that is the expected output. See your output, no? The your output part is your output. You are again giving geeks for geeks itself, no?
Uh, so
Okay, just do one thing. Just think about what will happen for geeks when k value is given as 2 and geeks is given. Think about it.
if it is given gigs. First, this part is fine. This part should like I'm removing the like the similar character. Suppose it is geeks, then if k is equal to
Uh,
2, then
but how are you? See, you are storing the indexes, no, in the stack. In the if part, you are storing the indexes. But how, in that case, how are you updating the frequency of the characters? That is not one. That is one thing that you should think again. Because you are like doing what? Like if it is
uh,
from line 25 to 31, you should think again. Like you are hashing the indexes, like you are showing the indexes in the pair, and then you are expecting that your second part of the stack gives you the count. Correct.
yes. Okay. Initially, if I'm storing this counter, then so in else part I can check basically that whether it's matching or not. That part I think I've missed. Like if my first element should be equal, like the current element should match with that, no, then only I can remove it. So I think I have to implement that.
Okay. But I think you are very close to the implementation part. You just need to think a little bit more logically.
If the top, like if the current top element, suppose if G is equal to suppose the next element, suppose it is E, then if E is equal to the third index, that is again it's E, then I have to, this I need to implement.
Okay. If it is okay. Now you're saying that if that is the case, then you are taking the frequency and then you are pushing it. Okay. Fine.
And yes, if then or else if it is I'm taking the I'm incrementing the frequency, then or else
Why do you want to write another else here?
if like 1 minute, oh I've closed, like if it is in this part, or else I can simply push the like the index, current index, that I'm saying.
Okay. Index.
Oh sorry, it should be one. I'm pushing the counter,
Correct.
sorry. Yes,
Absolutely. Okay.
I think now it should work.
Try it. Oh,
Yeah.
try to
Should I
submit it.
submit it? Okay.
Definitely.
Yeah.
Great. The first problem is solved under pressure. So all of you can give us a +1. Na? Like she has solved the first problem. All of you can give us a +1 in the chat and like the video as well for her. Give us a +1 for her. Okay. So she has solved the first problem. Initially, she was thinking a bit wrong. Basically, instead of I,
Yes.
if you had written one only, then it would have worked, right?
Yes.
Great. So this problem you have done. That was asked in Amazon Microsoft. Now let me give you the second problem. So okay. So I'll give it to you in the private chat. Okay. Yeah. So now just look at the private chat. You have been given the second problem as well.
This is okay.
Okay. So let us start off with this nostalgic problem. Now, what does the problem say first of all? Okay. So see, what does the problem say? The problem says that Tom and Jerry are bored in this pandemic. So basically, someone must have written this problem 2 years back. So these two people are bored in this pandemic, and they decide to play a game. So these two people are playing a game. Okay, so you can understand that maybe I'm asking a game theory kind of question. Now, I'll give you an integer n. Okay, so you will be given an integer n. Only one input will be given. That is an integer n. And now what you have to do is on each player's turn, right? So the players will switch their turns alternatively, and on each player's turn, the player makes a move. Okay. So suppose there's just on the screen. Let's say, right. Let's say you have n is equal to 6. Okay. Suppose.
Hmm.
Okay.
Hmm.
If you have n is equal to 6 now, so what you can do is, if you let's say you are playing the move, or let's say Tom is initially starting. Every time Tom will be
Hmm.
starting. So if Tom is playing a move, right? So in that case, what will happen? If let's say I give you n is equal to 6, so you can subtract that particular n with any of its divisors that is lesser than n. Are you clear with this? Like if n is equal
Okay.
to like 6 is given, so you can subtract
Hmm.
it with 1, you can subtract it with 2, you can subtract it with 3, but not with 6, because 6 is a divisor of 6, but 6
Hmm.
is like the divisor of like the number that the divisor with which I am subtracting the number, that divisor should not be equal to n, it should be lesser than n. So you can subtract 6 with 1, 2, 3, or 4, anything like 1, 2, 3,
Hmm.
whatever divisor you want,
Hmm.
and then you will get a new number, and that new number will be given to Jerry. Okay. Then
Okay.
Jerry will also do the same. Okay. Let's say Jerry, let's say you do this thing. Let's say, let's say somehow after some moves you give Jerry, let's say you give Jerry a number like 4. So Jerry can either subtract 1 from it or 2 from it. Let's say. Okay. That is an example. So after this, one by one, the players will be alternating their turn. The whatever new number will be there, the next player will be given. The next player will be given. Okay. Now, after in the end, what will happen? The player which cannot play this move, which cannot make the move, that will lose. Like if suppose I give you n is equal to 1, understand that when in the end, suppose after that, after several iterations, when the number is 1, okay, when the number is 1, then in that case, can you subtract? And 1 has only one divisor, that is 1 itself. And I told you that you can subtract the given number with any of its divisor except itself, right? The divisor that you are subtracting, that particular given number, it should be lesser than it. So 1 cannot be subtracted with 1, correct?
Yes.
So in that case, when the last number is 1, so whichever player gets 1, that will lose, correct? Because that player will not be able to make any move. Is this part clear?
Yes. Hmm.
So are you getting this question?
So I've got, but so like if suppose if I and Tom we are playing, then if you have given first, you have stated that if it is n is equal to 6, then like it should, suppose it's divisible by like 1, 2, 3, then if I've taken an integer of 3, right, then like for the next turn, suppose I cannot take I guess I cannot take this element, na 3. I have to like take all remaining elements. The question will be like
Uh,
this, I think.
can you tell me where you are stuck at again?
So I'm
Suppose
telling
n was
that
given as
if
6.
suppose n was given as 6, suppose if like the number which I'm dividing it was 3, right? So in
You are
that
not
case,
dividing, you are subtracting.
uh, we are
I said
subtracting,
I
okay,
said
we
you
are
will be.
subtracting a divisor of n. That is, if okay, if 6 minus, suppose if I'm subtracting a divisor like 3, then it should be 3, right? Currently it should be 3. And
Okay, 6 minus 3 will be 3. Okay, yeah.
huh, so from the current, and
So next
thus
player will get 3.
next player will get 3, okay.
Now 3 has two
But
divisors, 1 and 3.
1 and 3, so it should be divisible by 1, like it is so it should be 2
It's
again.
subtracted. It
Huh,
should
so
be
it is
subtracted
2
with 1.
again. Oh, okay, okay.
Okay.
So it is okay. For I guess for the first test case, I guess if n is equal to 2, then
See,
simply I can check
another
that
thing,
if
another thing I forgot to tell you, that Tom will be starting with the game. Okay, so Tom will be given an N, and you
okay.
have to tell whether Tom can win or not. Both players will try to win. Both players will play optimally, says that they will try to win. Yes, now you can proceed further.
I think for the first case, if like if I'm taking 2, if it is divisible by 2, then I think it Tom will win, because if it is divisible by 2, then like if n is divisible by 2, then we can return 0 thing, or else we can return 1. Can simply do that.
First of all, what statement you have said, I think you need to rethink of that. Okay. Then, secondly, when you correct your statement, then I want the reason or the proof for it. That is why I asked this question. So what did you say?
So I'm saying that I'm saying that if it is even, then like that person will win now, because Tom is starting obviously, so Tom will win. Basically, I'm saying that if like the number
But you
is
must have,
even, then he should win.
but there must be some reason behind it. No, that is what I'm asking.
So because divisor of any odd number is odd, right? So I'm saying that. So
Okay, let's
that
say
must be the
let's say you have
logic.
n is equal to 6. Let's say n
Hmm.
is equal to 6. So why does Tom win? Let's say Tom starts. You are saying that if Tom will start with an even number, then Tom will win. Correct? Are you saying this thing?
Yes.
But but can you tell me a solid, concrete logic for it? Logical thought process why you have come to this conclusion?
Um,
For hearing the logic only, I have asked this question.
Sir, if
You
so
must
I
like
am
see what I'm asking is I am saying that you must have come to this conclusion. You have come to this conclusion that n if n is odd, then you will do this. If n is even, then you will do this. Correct? But
yes, sir.
why? Why and how did you come to this conclusion? Na? Did you observe anything? Did you see anything? Like how did you come to this conclusion?
So first thing which I thought is that if the like if any odd number that will be divisible by any, like the divisor of any odd number, suppose I'm taking 5, then the divisor of that odd number must be odd. So I don't think in that case it will win. So that, for that I'm saying that, like if n is equal to 6, then again if Jerry is taking, like if I've taken 6 minus uh like 6 minus 3, if I'm dividing it with 6 3, so if I'm dividing it with subtracting it with 3, so it should be 3. So like if again I'm like dividing it with 1, then the divisor should be 1. So in that case, like that person, uh,
But you need to think like, are you able to explain the logic? Like you must have thought this logic. There must be some conclusion for it.
like for a particular person, I think like for a particular person there will be even and odd numbers, right? For a particular, suppose Tom will also get even number and like even and odd numbers both. So
Okay,
every
so let's
time,
say let's do one thing. Let's say that Tom starts with 15. Let's say for simplicity, let's say that Tom starts with 7.
okay.
Okay. So you can write on the screen that n is equal to 7. After line number, yeah, without commenting, you can write. So Tom starts with 7. I give Tom 7. Now tell me why will Tom lose?
So
You are
with
saying that Tom
this,
will lose.
so because initially, like we will have only two divisors, like 1 and 7. So if I'm dividing it with 7, we'll get 1. Like if I'm taking 7, then we'll get 1.
Okay,
So
so let's take
yes.
9. Let's take 9. This is a prime number. No? Let's take 9. Let's take n is equal to 9 now. 10, tell me. Instead of 7,
No,
take n is equal to 9 now.
no, if n is equal to 2, if I'm taking an even number, then the, like Tom will definitely win, because for 2 we have 1 and 2. So we are subtracting it with 1. So in that case, like Jerry won't have any possible combination as we have given in the question. So if it is even, then Tom will win. But if it is odd, then Tom will never win. That I'm saying.
I'm again asking the same thing. No? Like, what is the reason for this? Like, is there any concrete logic for this? You are just telling me, are you getting this? Like, most probably you are just telling me the solution.
No, I'm thinking like that, that if n is odd, then the divisors will be odd. In that respect, I'm
Okay, okay.
thinking.
So
So
let's take n is equal to 9. I'm saying take n is equal to 9 first of all.
yeah, yeah.
So you can write on the screen as well that you are taking n is equal to 9.
Okay. Yes.
So basically I've started, Tom is starting with 9. Now
Tom
tell
is
me
starting.
why Tom will lose, and whatever divisor theory you're telling, you can also tell that.
So we have only 3 divisors, right? 1, 3, and 9. If I'm not wrong, yeah, we should have 1, 3, and 9. So, like if I'm dividing it initially with, if I'm subtracting it initially with 3, then I think we will get n is equal to 6. So Jerry will get an even number. So in
So
this we
so you're
have,
saying, you tell me, okay, so you're saying that Jerry will get 6, but you said that the person who will get an even number will win. So in this case, Jerry will win.
in this
Okay,
case
fine.
Jerry should win. Yes, yes. In this case Jerry
Okay.
should win.
But
Like
what is the strategy for this
ultimately,
question? Okay,
like I can
let's say Jerry gets,
like uh,
let's say Jerry gets n is equal to 6. Okay, Jerry gets n is equal to
hmm,
6. Then
hmm,
what will you do?
hmm.
Can you tell me?
So the divisors will be 1, 2, 3, and 6, right? So if I'm dividing, like if I'm subtracting it with
Subtracting.
suppose 3, yeah, I'm subtracting it suppose with 3, then again Tom should get even, right? Tom should get odd. I'm so sorry. Tom should get odd. So in this case, we have only 1 and 3. So again, 1 will come, and like Tom will win the game. I'm saying that.
Not Tom will win the
Uh,
game. See, Tom had 9. Then
uh,
Tom gave Jerry 6, according to you. Then when like initially Tom had 9, then Jerry had 6, then Tom had 3. Tom has 3 now. So after that, what will you give Jerry?
so if suppose if I'm like subtracting it with 1, then I can give Tom odd number na. So in that case I'll have only 1 and 5. Suppose I'm
So I am
subtracting it
saying that,
with 1. No, I'm
why do
saying
you want to
that
give Tom odd numbers?
because Jerry wants to win,
Okay,
because every
but
player,
why?
everyone wants to play optimally, that's why.
Yeah, but why will the person getting odd number lose?
Because the divisors will be like for any odd number, the divisors will be odd, that's why I think so. It should
Okay.
never, like it will never win.
See, you are saying that if Tom is starting with an odd number, then odd numbers divisors will be odd only. Correct. So you are saying that
Yes,
if Tom starts with an odd number, then Tom will pass Jerry an even number. Correct.
yes, fine, yes,
Jerry will get
I'm
an
saying
even
that.
number. Then after that, you are saying that when Jerry gets even number, right? When Jerry gets even number, then what will you do? You will pass Tom what? Which kind of number?
Odd number.
Odd number, because even number will have both odd and even divisors. So you are
Yes,
saying that
because even number will
you are
have
saying that
both. Yes.
at least it will have one. So one is an odd divisor, and other numbers can be even divisors, right? So you are saying
Like
this,
the
right?
motive of
So,
Jerry will be to give odd, because like
but why?
that person wants to, because he wants to win. Both of them are playing
But why?
optimally. They,
But why will the person why will the person getting odd number lose?
because then that person will have only odd divisors, and if I'm taking even, like in case of Jerry here, that like Jerry will have both odd and even. That's why.
That is fine. But still,
Jerry is
you need to.
playing.
You're just one.
No, Jerry
Everybody
is
is
playing.
playing to win.
Yes, everybody's playing to win. So Jerry can give Tom always odd number. Like
See,
it's quite
see.
possible. Like
But still, you're not telling me the reason for this, no? Why the person getting odd number will lose? Because if a particular person, let's say Tom starts with even. Let's say Tom starts with even, then Tom will give Jerry an odd number. Correct. Then Tom will again get an
yes.
odd number. Then after that, Jerry will get odd like Tom starts with even, Jerry gets odd, then Tom gets even, then Jerry gets odd, right? So in the end, what will happen now? If Jerry keeps on getting this odd number, then the last odd number that Jerry will get will be what? The last odd number that Jerry will get will be what? 1.
That will be 1. Yeah, that will be 1.
Yeah. So where the person who gets the odd number, that is 1, will lose, na? Right? If
Yes.
somebody keeps on getting the
Yes.
odd numbers, then at one point of time, if the person keeps on getting odd numbers, then at one point of time, a particular person will get, the person who is getting odd numbers repetitively, he will get 1, and 1 is
He
an
will
odd number which will
lose.
make you lose, na? So that is
Yes.
one thing that you were not explaining, na? That one by one, if you keep giving a person odd number, then he will not be he will in the end he will get odd number which is 1, and when you get an odd number 1, then you cannot win. Okay.
Yeah, actually, I wanted to say that only, that if a person like Jerry, for here it is Jerry, so if he can repeatedly give him odd number, na, because he wants to win. That's what I was trying to say.
But you should have said that the person who gets odd numbers, so at one point of time he will get an odd number which is 1, and 1 will make you lose.
And that, and he'll lose. Yeah.
Right. That is the whole point. Okay. Great.
Yes.
But I have a solution of this video on YouTube, so you can search Tom and Jerry GFG practice. You'll get the solution for it. Okay. Now you can stop sharing your screen, and can you tell us about your experience with this interview? Like how your experience has been like in today's interview?
So it was wonderful. I learned a lot. It was really wonderful. I never had like live experience, so yeah, it was wonderful.
Others can also tell us how they like the format of this interview and the questions that we took. Obviously, the questions were quite good. Okay, I'll say that the second question was also good. Don't think of it as easy question, because the reason is the main thing. Okay, and she was almost able to explain the reason as well. Okay, now do you want some feedback from my end as well?
Yes, sir, definitely.
Okay. So see, I saw your resume, and you have solved 900 or 1000 plus problem, right? By the end of this month, maybe you will solve 1000 like plus problems. Okay, that is fine. But I will again say that one thing that I want you to improve on is a little bit explanation part. Like you were coding really fast. Like initially you were coding it really fast, and when you when you got the question at Tom and Jerry, then I think you had solved it maybe earlier. I'm not sure. So what I could observe is that, okay, but still you were not telling now what was your thought process of coming to this conclusion. So you can sometimes convey your thought process as well. But overall, I liked the way that you approached the problems and the way that you gave solutions. It was really, really good. And I think within a few months, you'll be having a really good placement. Like you'll crack a good placement at least.
Thank you so much.
At least Amazon is coming. Okay.
Thank you so much.
Okay, fine. Great. Others can also give us a +1 and hit the like button quickly. Just quickly give us a +1 in the chat, guys, and hit the like button. Okay, so thank you, Aditi, for joining in for today. Now I'll talk with the audience for 1 second, and then I'll end this webinar. So this was Aditi today. So Aditi, like she has given a good interview today. So some people were commenting that they want to also give us give the mock interviews with us. So what you can do, guys, is there's a form given in the link of this video. Like in the link of like in the description, there's a form given, so you can fill that form. Okay. And before going, I'm again saying that please hit the like button and give a +1 in the chat if you understood. After this video is over, you can comment helpful after this video is over. That will help us a lot. And if there is anything that you want us to improve or anything like that, you can comment that as well. We'll improve. So thank you everyone for joining for today, and all the best for the future. Keep coding, guys, and good night.